Hello and welcome to today's screencast, which is going to be focusing on the second energy system that we need to be studying at A-level PE, and it's going to be the glycolytic system. Okay, so we've already looked at ATP on its own. Now we've learned that ATP is the energy currency of the body, and it's the only usable source of energy that we have. And we know that when ATP is broken down by ATPase, we have energy, high intensity anaerobic energy or work that lasts for approximately 3 seconds. And we've realised that once this is depleted after those 3 seconds, we come across our first energy system, which is the ATP Pc system. Now again, the ATP Pc system provides high intensity anaerobic work for us. Now we've learnt that the fuel Pc is what's broken down to resynthesize the ATP, and that provides us with 1 ATP. It provides us with energy for approximately 10 seconds. An example of that would be the 100-meter sprint. So once this PC, this phosphocreatine, is depleted after 10 seconds, we can no longer resynthesize ATP using our PC stores because they're depleted. We have no more left. So where it takes place in the muscle sarcoplasm, there is no more phosphocreatine left for us. Therefore, we have to go on to add a different fuel to help us resynthesize this ATP. And this is when we're thankful that we have the glycolytic system. So we start with ATP, which is not an energy system. Then we go on to our first energy system, the ATP Pc system, to resynthesize ATP. Then we come on to this second energy system, which is the glycolytic system. Now, before we start this, we need to look back at what we've already kind of studied at A-level PE. We've already looked at nutrition. Now, the reason we've looked at nutrition is because we learn about nutrients such as fats and carbohydrates. And if we specifically talk about carbohydrates now, we know that carbohydrates provide us with the energy needed for training and competition. So when we eat our carbohydrates, such as our starchy carbohydrates, our rice, our potatoes, we convert these carbohydrates into glycogen, and then we store them in our muscle and our liver. Okay, so this is the aspect of what we're going to be going on to now when we're discussing the glycolytic system. So for today's screencast, what we're going to be doing is we're going to be able to explain how the glycolytic system provides energy for sporting activities. Now our lesson content is really going to focus on evaluating the glycolytic system, talking about the advantages and disadvantages of this system. So anaerobic system, number 2. So again, it says straight away here, the glycolytic system is an anaerobic system. Okay, so we break down glycogen and glucose, which you're going to figure out, without oxygen being present. Okay, so what we start with is, well, let's start with, it actually takes place in the muscle sarcoplasm. Okay, so similar to the ATP Pc system, it takes place in the muscle sarcoplasm. And we start with glycogen. So we've broken down our carbohydrates that we've got, and we have glycogen, which is stored in the muscle and the liver. So it's stored in the muscle, it's stored in this muscle sarcoplasm. Now we have to break down glycogen into glucose, and we do this with an enzyme called GPP, also known as glycogen phosphorylase. Now, I think it's important for this first time you're seeing this terminology as you write down glycogen phosphorylase. However, in your exam you only have to put GPP. If you think of the enzymes that broke down ATP originally, ATPase, if you think about the enzyme that broke down phosphocreatine, which is creatine kinase, glycogen phosphorylase, all of these enzymes, they end in an ase. Okay, so that's something that we can start to think about. So we start with glycogen stored in the muscle and liver. So glycogen stored in the muscle, we break down glycogen into glucose by the enzyme GPP. Now glucose, this is where we actually get our ATP from. This is where we get our ATP resynthesis from. Okay, so what happens is glucose also needs to be broken down to provide us with the energy we need. So glucose is broken down by an enzyme called phosphofructokinase. Again, we can have phosphofructokinase as PFK. So glucose is broken down by PFK, and it is turned into, or the product of that breakdown is pyruvic acid. This, what you're looking at right now, creates 2 ATP. So the breakdown of glucose by PFK provides us with 2 ATP and pyruvic acid. We don't need to know any kind of ADP plus P plus E, all of that. We just need to know the product is glucose is broken down by PFK to create 2 ATP, and pyruvic acid is created. Now, this is what you're looking at right now is known as anaerobic glycolysis. Okay, so the breakdown of glucose in the absence of oxygen is called anaerobic glycolysis. And as a result of anaerobic glycolysis, we create pyruvic acid. Now, this provides us with energy for high intensity activities such as 200 meters, 400 meters track events, okay, tracking back in football, and so on. Now, because there is no oxygen present, this pyruvic acid is converted by an enzyme called lactate dehydrogenase into lactic acid. So I'm going to get that up now. And then we've all heard of the term lactic acid. So what happens is LDH, lactate dehydrogenase, converts pyruvic acid into lactic acid. And I'm sure we've all experienced lactic acid. It's painful. You don't need to get this down in your notes, but just so you know, lactic acid is a protective mechanism from the body. It's painful for a reason. It's the body telling you we're running out of glycogen and glucose. We do not want to exercise anymore because we're not going to be able to. So it's actually a protective mechanism. You don't need to write that down, but that's just something for you to understand. Okay. So the process so far is glycogen stored in the muscle, specifically muscle sarcoplasm, is broken down by GPP to create glucose. Glucose is broken down by the enzyme PFK to create 2-ATP, and because there is no oxygen present, we have pyruvic acid is converted by LDH into lactic acid. This process here is known as anaerobic glycolysis because there's no oxygen present. Now, just so you know, when we go onto the aerobic system, when there is oxygen present, pyruvic acid, we take a different course, we take a different step that provides us with more energy. But what we need to know, glycolytic system, it's anaerobic, there is no oxygen present. Therefore, pyruvic acid is converted by LDH into lactic acid. Now, this causes us a problem because this has a knock-on effect. So other things happen which inhibit enzymes, inhibits us to get energy. So what happens is, when we get lactic acid, we get an increase in blood acidity. Now, we get an increase in blood acidity pretty much the same as we get a decrease in this blood pH. So our blood now is really acidic. Now, what this causes is enzymes to denature. So this denatures enzymes, i.e. GPP, PFK, LDH. These can't do their job, which means we can't break things down, we can't get energy. So, lactic acid means that we get an increase in blood acidity, a decrease in blood pH, which denatures our enzymes, which gives us the end result of fatigue. And we really need to know this fatigue, it's onset of blood lactate accumulation, OBLA. So this, right now, as you're looking on your screen, is the whole process of the glycolytic system. So I really want you, for the lesson, we need to know this. You get your main marks come from glycogen is broken down by GPP to create glucose. Glucose is broken down by the enzyme PFK to create 2-ATP and pyruvic acid. This is anaerobic glycolysis because there's no oxygen present. Pyruvic acid is converted into lactic acid via the enzyme LDH. You get your main marks for that part. Then this extra information, this kind of part here is really important now. So because of this lactic acid, we get an increase in blood acidity, a decrease in blood pH, pretty much the same thing, which denatures enzymes, which means we get an onset of blood lactate accumulation, OBLA, fatigue. We can no longer have a muscular contraction. We have ran out of energy for a muscular contraction. We get 2-ATP from the glycolytic system. So, you need to make sure you have got that drawn, you know the process. Now, summary, okay, so stuff we really need to be aware of is what the fuel is. Is it aerobic, anaerobic? What is the time? So I'm going to tell you the time. The energy yield, the byproducts, the complexity of the kind of breakdown of glycogen, and then the site of the reaction, support an example. So, fuel, glycogen and glucose. It's an anaerobic energy system. The time is, it kicks in just after that 10 seconds, or just around about 10 seconds when we run out of our PC, and this goes for approximately about 3 minutes, okay. If you're thinking 3 minutes now, that's why you're thinking of your 400 metre track events, your counter-attack in football, your tracking back in hockey. rugby, so on. Energy yield, 2 ATP. Byproducts, really bad byproduct, lactic acid, not good at all. Complexity, it is a simple reaction. That process you have just seen is simple. Site of reaction, the muscle sarcoplasm. Sporting example, I've gone through 400 metre sprint, recovery run in hockey, football, rugby, taking over someone in a marathon and then extending your lead. There's loads, okay? The main thing we want, 400 metre sprint. So, they are your Cornell notes for lesson. Please make sure you have all this information down, make sure you have questions provided, and I'll see you in lesson to evaluate this. Thank you.